Question number 16. A satellite system employs QPSK modulation with 40% excess bandwidth. So it is using QPSK modulation with 40% excess bandwidth per carrier, including Godband. The voice channel use 64 kbps PCM coding. The number of channels supported by 36 MHz bandwidth of the transponder in the bandwidth limiting case. The question may be looking very difficult and confusing for you, but the question is very simple if you know few formulas which I am going to teach you. And what he is asking finally is the number of channels required. This question is very simple if you know the formulas. Okay, fine. So before starting this question, I would like to say that this question is quite common in GATE and ISRO. So try to memorize the formulas which I am going to teach you, and also learn the extensions which I am going to teach you. Okay. We will see three concepts in order to understand this question and to solve this question. First one, we should know what is bit rate, or some people will call it as data rate. Next, we should know what is baud rate. Some people will call this also as symbol rate. Also, we should know what is excess bandwidth. Excess bandwidth. Okay, fine. So let us discuss each one of them in detail. So I'll be discussing bit rate and symbol rate together. Bit rate versus symbol rate. Okay, suppose you have one bit of information. This one bit of information, whatever you have, it can be either 0 or it can be 1. So one bit can be filled with either 0 or 1. Means, in other words, you have one blank. That blank can be filled with 0 or 1 in case of binary. Okay, we are dealing only with binary transmissions. Okay, suppose you have 2 bits. You say to your friend that you have some 2 bits of secret code which is in binary. Means, what are the maximum possible 2 blanks you have? That can be either 0 0, it can be 0 1, it can be 1 0, or it can be 1 1. Maximum possible combinations are 4. Okay, in case of 2 bit. In case of 1 bit, the maximum possible combinations are 2. Here 4. Okay, let us see 3 bit. Suppose you say to your friend that you have some 3 bit code which is very secret and you will not reveal to someone. So the 3 bit code can be 3 blanks. It can be 0 0 0, 0 0 1, 0 1 0, 0 1 1, or 1 0 0, 1 0 1, 1 1 0, or 1 1 1. So total how many combinations? So total combinations are 8. So what I would like to say is, if you have one bit of information with you, then it can be 2 possible combinations. These 2 possible combinations are called 2 symbols. So 2 bits can have 4 possible combinations. In other words, it has 4 different symbols. This is one symbol, this other symbol, this other symbol, this other symbol. Suppose if you have 3 bit of information, then total you'll have 8 symbols. So suppose if we have b bits, if we have b number of bits, then the number of symbols possible are, maximum possible combinations are 2 power b symbols. So the relation between number of symbols and number of bits is given by s is equal to 2 power b. S indicates number of symbols, b indicates number of bits. So try to memorize this first formula. Next, bit rate versus, see, this is a relationship between number of symbols and number of bits. Now if somebody asks what is the number of bits b equal to, then you can simply write it as log 2 to the base log s to the base 2. So try to memorize the second formula because we'll be using this very frequently. I'll be remembering this and I'll be using this frequently. B is equal to log 2 S. Fine. Now let us see next concept called, that is the previous was the relationship between number of bits and number of symbols. Now let us see relationship between bit rate and baud rate. Bit rate versus baud rate. Baud rate is nothing but once again symbol rate. Fine. Consider a 2-bit data. So 2 bits means it will have 4 symbols. So 0 0 0 1 1 0 1 1. These are the symbols. So just try to understand carefully. I am taking a symbol 1 0. For instance, I am taking a symbol 1 0. This is my secret code, or say it is my password. So 1 0 is my password, or it is my symbol. So this symbol has how many bits? It has 2 bits. First bit, this is the first bit, and this is the second bit. So in order to transmit, I want to transmit this symbol. Say I am sending this through an email, or I'm saying, so what my intention is, I want to transmit this symbol. So in order to transmit this symbol, how much time it takes, that I would like to calculate. So time taken for a symbol to transmit, time for symbol transmission is nothing but time taken for first bit to transmit, time for the first bit transmission, plus time taken for second bit transmission. Okay, so I can write it as TS, time for symbol duration. Some people will call it as symbol duration is nothing but first bit duration plus second bit duration. Suppose if the bit duration of 1 and 0, if it is same, let me assume that TB1 equal to TB2 equal to some TB. Assume that they are same. Then in such case, what you are going to get is symbol duration is nothing but 2 times bit duration. This is for 2-bit information. Okay, suppose if you have 3-bit information, then symbol duration will be 3 times bit duration. So like that, so suppose if you have b bits of password is made up of b bits, then symbol duration is b times bit duration. Try to memorize the second formula. So this is the second formula. Duration, if you write in terms of rate, what you're going to get, RB, just reverse, RB is equal to, because T is 1 by R, rate is nothing but frequency, time is inversely proportional to rate or frequency. So RB is nothing but B times RS. You already know what is B. B is nothing but log 2 S, symbols S. So fine. So here is the summary. Number of bits equal to log base 2 S, and bit rate RB is equal to log base 2 S multiplied with RS, symbol rate. Then third one I didn't explain, but try to memorize this formula. We'll see in the upcoming classes. Bandwidth, it's a excess bandwidth. Actually, it's not simply a bandwidth. Excess bandwidth is nothing but actual bandwidth RB multiplied with 1 plus alpha. Alpha indicates excess value. Okay, so suppose if anything is increased by 40%, then what you will say, say there is an x is increased by 40%, x plus 40% of x. So this is nothing but, if you take common x, then you will left with 1 plus, like this. So same format, RB is like x, 1 is same, plus 0.4 is like percentage of excess value. Okay, so that is a thing which you need to understand. Fine, now let us solve this question. Okay, there is a small correction. This should not be RP. I'll indicate. Yeah, this is not RP. Just change it to RS. It is symbols. How many symbols are this? RS. Please make a correction. Very important. So this is RS. Now let us come back to our question. So what is given data? You can read the question. It is given that 40% excess bandwidth. So I have indicated already 40. Alpha is 40. Then QPSK modulation and 64 kbps PCM coding and 36 bandwidth of transponder. So same thing I indicated here. Alpha is 40%. QPSK. Q means quadrature. So symbols will be 4 quadrature, 4 symbols. So bit rate is given, it is channel bit rate. So 64 kbps is given, and the total bandwidth of the transponder is 36 megahertz. So this is the given data with which we can solve the question easily. So let us try to find the excess bandwidth. Excess bandwidth formula, first formula is equal to RS. Symbol rate it is not given, it is given bit rate. So write RS as it is into 1 plus alpha. Alpha is 0.4. So this yields to 1.4 RS. Now let us find what is RS. So RB is given. So let us try to use the second formula. So second formula says RB. RB is given 64 kbps. 64 kilo kbps rate is nothing but RS into log 2s, log base 2s. S is 4. So this yields to 64 kilo is equal to RS multiplied with log 4 base 2 will be 2. So therefore RS will be 32 kbps. Now let us find the excess bandwidth. Bandwidth excess is nothing but 1.4 times RS. RS is 32 kbps. This yields to, if you multiply, this yields to 44.8 kilohertz. Now the question is about number of channels. Number of channels is nothing but total bandwidth of the transponder, in which how many channels of our whatever we got 44.8 will fit into it. It's nothing but total available bandwidth of the transponder divided by bandwidth of the each channel. Total bandwidth of the transponder is given as 36 megahertz. 36 mega is nothing but 36,000 kilohertz. Okay, mega is 10 power 6. So 3 zeros I'm splitting here, so it will be in kilohertz. 36,000 divided by bandwidth of each channel is 44.8. Just now we obtained 44.8. Okay, fine. Now, so if you divide this, you are going to get 803.57 channels. But in the question, if you see, he is clearly mentioned what is the number of channels in the limiting case. Limiting means just round figure, down round figure. Okay, so just make the floor of it, not the seal. Okay, so just remove whatever you got after the decimal point. So number of channels will be 803. So let us see the options. So the right choice will be option B. So this is the approximate answer. Thank you. Now let us see the extension. These formulas are very important for GATE, IES and ISRO. So try to memorize these two formulas. With these two formulas, lot of questions you can cover. First one, bit rate RB is equal to RS into log s to the base 2. S indicates number of symbols. Some people instead of s they'll write it as M, capital M, doesn't matter. Fine. Second one, excess bandwidth is defined as RS by 2 into 1 plus alpha for baseband modulation schemes, RS into 1 plus alpha for passband modulation schemes. So for baseband it is by 2, for passband by 1, nothing is there, by 1. Okay, so for baseband indicates low frequency, base low. Passband indicates high frequency, they are at very high frequency. Fine. So what are these baseband and passband modulation schemes? Let us see. So generally the digital modulation schemes, any digital modulation scheme can be classified into two categories. One is baseband modulation schemes, other is passband modulation schemes. The name itself tells it's a baseband. Means it's at low frequency, very low. So pass band, it should pass some high frequency, so it is at higher frequency, just like pass band filter, it's at higher frequency. So pass band, so high frequency. The examples for baseband modulation scheme, you need to memorize this. There's a PCM, pulse code modulation; DPCM, differential pulse code modulation; DM, delta modulation; ADM, adaptive delta modulation. Whereas for passband or high frequency modulation, the examples are amplitude shift keying, phase shift keying, amplitude shift keying, frequency shift keying, phase shift keying, and finally quadrature amplitude modulation. Okay, so you need to memorize this examples for baseband and passband modulation. In exam he'll be clearly crystal clear, he'll be giving what type of modulation he have used. Simply highlight that point, and you need to use whether rs by 2 or simply rs into 1 plus alpha. So if we go back to our question, you can clearly see that. Okay, let us go back to our question. So you can see here, it is clearly, I have highlighted, it is QPSK. Q means quadrature. This indicates M value, M or S value. Symbols are 4. Remaining part indicates type of modulation. It is clearly giving PSK means phase shift keying. This comes under high frequency. You can refer my notes which I have taught you just now. So high frequency. Hence that's the reason you need to use RB equal to RS into 1 plus alpha, which I have used in the solving. So try to memorize this. And one more thing I would like to tell you, that if you have noticed, the formulas in which I have written is very simple to memorize. RB, bitrate, you need to remember. Excess bandwidth, you need to remember. Always RS will be on the right side. Okay, right side will be RS. Okay, right side RS, just like right side, like that you remember. RS into log S to the base 2. Here also RS. I've seen many people, they'll be confusing and writing RS equal to RB, something it is not correct. So RS right side, it should be always right side. Okay, try to memorize. Thank you.